Hi there, welcome back to the DevOl. I am Roman and today we are going to talk about the fold function. So the fold function is a function that is mainly used for collection modules or for different kind of collections like lists and sequences, enumerables, arrays, etc. etc. It is available for other data types, but we're not going to talk about this now. So today we are going to talk about the fold function in the list module. And in order to be able to do this, we have a look at how the function is defined within the awesome Ionide info panel. So within here, we see that the fold function has three input parameters: folder, state, and list. And we see that the function has two type parameters, t and state, in here. And the list function is of type t, so it's of type integer or string, so one type within the list. And the folder function is a function that takes some kind of state and some value of this type t that the list has, and it returns this type state. And then we have the other parameter, which is called state or initial state, which is also of the type state that is fed into the folder. So what are we going to do with this today? The first example, we want to add all even numbers within the list together. This is, of course, not very realistic, but it's nice to show how fold works in general. Later on, we will see something more realistic maybe. So in here, we have a list in F#, which goes from 1 with a step counter of 3 to 30. So when we run this here, we see we have 1, 4, 7, etc. And this is what we're going to take as the input for our fold function. So this is our list in here. And when we have this, we need some kind of folder function. So this is the function for which each item in the list gets fed into this function. And as we see here, it gets a state, this kind of value from the list, and it returns a state. So we have a state and a value. So we want to add all even numbers together. So if the value mod 2 equals 0, then we know that the number is even. So what we're going to do then, we are going to return the state, the current state, plus the value, which is even. And in the other case, we just return the current state. So we get rid of the value. And our initial state is just 0 because we are adding up. We just put 0 in there. So we have a start value that we can actually fed into the function, because each entry of the list is fed into the folder step by step, and the last value that came out of the folder is taken as the state. And for the first run, we don't have a state, and this is where the initial state is for. So we have our list fold function here. The first parameter is the folder. The second parameter is the initial state, and the last parameter is the list. And when we run all this, we see that we have a folder that goes from an integer and an integer to another integer. The initial state is 0, and we see that all the even numbers together, 4, 10, 16, 22, and 28 together are 18, are added together. So in order to be able to see this better, how this function really works, I will put some debugging statements in there. So I will print out the current state for the function, the current value, there's also fed into the function. And if the value is even, we are going to say that the value is even, and we return the new state. And if the value is odd, we just say that we return the state. So when we run this, we see here, we start with the state is 0 and the value is 1. So the state is 0, this is our initial state. The value is 1, this is the first entry of the list. So 1 is odd, so we're returning the old state, which is 0. In the second run, the state is 0, because this is what we were returning, and the value is 4. And now, because this is even, we return the new state, which is 0 plus 4 is 4. In the next run, we say the current state is 4, the new value is 7, this is odd, so we're returning the old state. And here in the last one that I'm showing you is we have the state is 4, the value is 10, which is even, so we add 10 plus 4, which is 14, which is the new state of this function, and so on and so on. So of course this is a very easy and simple and contrived example, because normally we don't really have some small list where we are adding just the even numbers. And what is also pretty simple in this example is that both the state and the values within the folder are of the same type. So what the fold function can actually do is that we can use the values from a specific type from a collection and transfer or transform it into a completely new type. And this is where a lot of the power of the fold function is based on. So the example that we are using to show this is, imagine you use your normal Windows PC. And of course Windows asks you that it wants to update itself from time to time, and most of the time this for you is the worst possible time that you can imagine. So Windows asks, do you want to update or do you want to actually defer the update? And imagine there is a log, and Windows writes down how often you are deferring or you're doing the actual update. And now you want to know how often you have actually done this. And I reckon most of the people have deferred the update much more often than they're actually doing this. So we have this type here, which is a log that says if the Windows update was accepted or deferred. And we have a log result, which gives me the number of how often I have accepted the update and how often I have deferred the update. And imagine we have read out the log, we have parsed all this into those types, and we have a list of a couple of entries when the Windows update was accepted, deferred, etc., etc. So now we want to use list fold for this. So the list is what we already have. So now we need to think of the type that we get out of this. And of course, this is our log result up here. And the type that we want to get out of this is the type that we need to fed into. So we need an initial state in here. So the initial state in our case is that the Windows accepted and update accepted and deferred are both equal 0. So let's build a folder. We have the state and we have our value, which is an entry in the list, which is a log entry in this case. So let's name it like this. So we match over the log entry, or we do pattern matching, and we say when the Windows update was accepted, we just take the state, which is this log result, and update the Windows accepted with the old value plus 1. And if the update was deferred, we update the state with the old Windows update deferred plus 1. So we fed all this into our fold function. We put the folder in there, the initial state in there, which is actually written in the wrong way here, sorry. And we put the list in there. And then we see down here that we get our results. We have the initial state, which is a log result. We have the folder, which takes a log result and a log entry. So completely different types in there. And we return a log result, which is that we accepted the update 3 times and we deferred it 8 times. So, to recapitulate, we have the list of our entries. We have a folder function that takes them and transforms them into the new type that we want to get out of this. And for the first run through the system, so for the first entry in the list, so for the first time that we use the folder function, we need an initial state which is also fed into the folder function. And that's what there is to the fold function for collections. I hope you got something out of this. See you in the near future. Bye bye.